a review on weather. And so we're going to talk about weather fronts and hurricanes and tornadoes and thunderstorms, but not in that order. So I have a couple of slides. Here are your goals, all 6 of them. Like, remember, this is a review video, so it's jam-packed full. Take a second, copy down all 6, and I'll see you in a second. So air masses are huge bodies of air with similar temperature and moisture content. The characteristics can change as they move over different geographic features. So, for example, if they move over water, they pick up more moisture. If they move over a mountain range, they might be forced up due to orographic lifting, which will form clouds and produce precipitation on the windward side of the mountains. Or if they experience more solar radiation, they might warm up. So, we classify air masses by overall temperature and the surfaces over which they form. So overall temperature, we have 2 main temperatures. So we have polar air masses, or ones that are formed up here at high latitudes, and we represent those with a capital P. And those have cold air. And then we have tropical air masses, or those that are developed near the equator. And we represent those with a capital T. And those are warm. And then we also look at the surface over which they form, which kind of determines what their moisture content is going to be. So if they're maritime, we use a little m, maritime, over the ocean, like marine, maritime kind of sound the same. So they developed over water, and so they're going to be a little bit more moist. And then continental, we use a little c to represent that, continental. And they developed over land, so they're going to be a little bit more dry. So we can combine those things to make the 4 different basic types of air masses. So we have continental polar, which develops in the high latitudes over land. And so those are going to be cool and dry air masses. We have continental tropical air masses, which develop over land near the equator, and those are going to be warm and dry. We have maritime polar, which develop over the ocean in the high latitudes, and those are going to be cool and moist. And then maritime tropical, which develop over the ocean near the equator, so those are going to be warm and moist. Okay, moving on. So next we have fronts. Fronts are just the boundary that form when 2 air masses of different characteristics meet up. So when 2 air masses that are different meet up, we get a front. So we have a couple of different kinds of fronts. So we have warm fronts. Warm front is warm air moving into an area that was dominated by cold air, but it's not going to be dominated by that anymore. They move pretty slowly, and they create light to moderate precipitation for an extended period of time. So we have moderate precipitation for an extended period of time. It's shown on a weather map with the little red semicircles pointing in the direction that the warm air is moving. Okay, and then we have cold fronts. Oh, so hold on, backtrack. So make sure to draw these little symbols, the little red semicircles, in the box to the right of warm fronts on your notes. So cold fronts is when cold, dense air is moving into a region that was dominated by warmer air. So we have the warmer air, but the cold air is coming in and taking over. So as the cold air pushes in, it shoves that warm air up. Since these fronts, they move very quickly. So cold fronts move quickly. They result in heavy precipitation because that warm air gets shoved up, and so it cools really quickly and forms these big crazy clouds. And then cold fronts are shown by blue triangles pointing in the direction that the cold air is moving on the weather map. So behind the blue triangles are cold air, in front of the blue triangles are warm air. So make sure you draw some of those blue triangles in that box to the right of cold fronts on your notes. Then we have stationary fronts. So stationary fronts is when a warm and a cold air mass sit next to each other and they don't really move. So we can have really long periods of cloudy weather with possibly light precipitation. We show it on the map with the red semicircles pointing the direction that the warm air could be moving, pointing into that cold air, and the cold blue triangles pointing into the warm air, because we remember the air that these symbols symbolize is behind the symbol. So the cold air is behind the blue triangles, the warm air is behind the red semicircles on a map. And then we have occluded fronts. Occluded fronts are kind of crazy. So it's basically when a cold front overtakes a warm front. So let's look at this pretty big for a second. So first of all, you have your cold front and you have your warm front. And since cold fronts move faster than warm fronts, it kind of catches up. So cold front, warm air in the middle, cooler air on either side. Okay, so your cold front is moving faster, it catches up to the warm front, and it starts to overtake it. So this really cold air is overtaking the cool air, and all that warm air that was in the middle here is now being forced up really quickly in both directions. And then finally the cold front will take over and you'll get an occluded front, and we can show an occluded front on a map with either the red semicircles and blue triangles, and they're both going to be pointing the way that both fronts were moving, or you can make these purple. So make sure to draw that in your box to the right of your notes really quickly. And with occluded fronts, you get really complex, kind of weird weather, and that's all you need to know about that. So we're going to hop over for a second to a previous video, and we're going to talk about thunderstorms. So to make a thunderstorm, the atmosphere has to meet three conditions, or we have to have three ingredients. So the first one is moisture. We have to have rising, unstable air. And that's where some warmth can come into play. And we have to have a lifting mechanism. Once we have these conditions, so we have the sun has warmed the earth, so we have some warm air full of moisture, or it has come and hit a mountain. Either way, the moist air is being forced to rise, and as it gets up high in the atmosphere, it starts to cool. Because we know up higher in the troposphere, it starts to cool. And so when water vapor gets cold, it condenses and forms water droplets or ice crystals, and we get a lovely cumulus cloud. So right now we have lots and lots of updrafts of warm, moist air. We have the mature stage of the thunderstorm, so we have a towering cumulus cloud. It's nice and tall. This is the stage where we're going to get lightning, tornadoes, hail, and other severe things like really strong winds. So we have our warm, moist air going up into the clouds. We call these updrafts. And once it gets up to the top of the cloud, it cools, condenses, and sinks. So we get condensed water droplets, or maybe even hail, and it starts to sink. So the heavy rain starts to sink, and it brings the cool air with it. So we get cool air downdrafts that are starting to cool the ground. Then we have our dissipating stage. So after the ground has been cooled, we don't have any more warm air rising or any more moisture to be added to the clouds. So we have more downdrafts than we have updrafts. So during this stage, the clouds are just kind of getting rid of the rest of their moisture, and they're still going to expect heavy rains, but it's going to taper off towards the end. We're back, and we're going to talk about tornadoes. So something you need to know about tornadoes, the first thing that needs to happen for a tornado to form is for a thunderstorm to form. So tornadoes, the definition of tornadoes is a violent windstorm that takes the form of a rotating column of air called a vortex. So first we have to have a thunderstorm to form, and then we get the formation of a mesocyclone. That's M-E-S-O-C-Y-C-L-O-N-E. You can see that word right here. All right, so we have our thunderstorm here forming, and we have our winds that are kind of spiraling horizontally. And then in the thunderstorm, we know there are updrafts. Those updrafts pull that rotating column of air up into the thunderstorm inside of the cumulonimbus cloud. And then the downdraft from the rain being pulled down and all that stuff can kind of help that spiraling cloud come towards the ground and form a tornado. A tornado does not form 100% of the time. A tornado only happens once that cloud makes contact with the ground. Otherwise, it's called a funnel cloud if it just stays up in the sky. Now we're gonna zip over and look at a video from a while back about hurricane formation.
Today we are talking about hurricanes. In other parts of the world, we call hurricanes different things, like cyclones and typhoons, but the scientific name for hurricanes is a tropical cyclone. So hurricanes are also known as tropical cyclones. We're going to go over the steps in tropical cyclone formation twice. First, we're going to have a side view, and then second, we'll do a top-down view. So first, all of this warm, moist air rises from the ocean, and that leaves kind of a void below. We're leaving a low pressure system below. So the warm, moist air is rising, and we know as warm air rises, it condenses, and the water vapor turns into water droplets, and we get some nice clouds. And we also know that winds blow from areas of high pressure to areas of low pressure, so off to the sides, somewhere out else in the ocean, we have areas of high pressure. And those areas of high pressure, the winds are going to blow from high pressure to low pressure, so we're going to get winds coming in to the low pressure area. And because the air has been taken up from this location, this new air is going to take its place. It's going to warm up, and it's going to get moist, and it's going to rise. So we have even more warm air rising and forming even more clouds. So this process continues. We continue to, and then it starts rotating. So we know that for low pressure systems, they rotate counterclockwise. So all of these clouds and this air masses, they're going to start rotating. So they're going to go around this way. And all of these clouds are going to go around. So we have our storm that is rotating counterclockwise because we're in the northern hemisphere.
And we're done! So hopefully this video jogged your memory on all sorts of kinds of weather that we have already talked about and that you need to review for your final exam. Alrighty, I will see you in class, and we will do some activities to make this stuff stick better in your minds.